together a pioneering event, so bear with us, please be kind, things might go wrong, but it is going to be amazing. So we've got innovators from the UK, mostly in the north, which is great, and the Netherlands, our North Sea neighbours. We're experimenting how an online event can work. We'll be sharing everything openly afterwards so we can all join in and hopefully learn. And what I'd like to do now is thank the ODI Leeds team. So Amy Evans, Giles Dring, Stuart Lowe and Patrick Lake. What an amazing job they've done. And you might even see Tom Forth popping up now and then. So we've got, over 2 days, we've got 4 sessions of about 2.5 hours each. First one is Open Data Saves Lives, which comes up in about 5 minutes. Open Data Saves Lives, although it sounds really easy, does seem to be quite a difficult concept to make happen. The next session this afternoon, Responsible Data Collaboration. Essentially, this is all about doing the right thing. But we all know that collaboration should be easy, but man, do we make it hard sometimes. Tomorrow morning, Tuesday morning, we've got Mobility in Modern City. ODI Leeds, we love buses and bikes, absolutely love them. So we're really looking forward to how this session goes, and especially learning from the Netherlands, who we know are a little bit ahead of us on that. And lastly, something that we've all come to get used to is social interaction in a distance world. What's going to happen next? How are we going to navigate it? That's going to be really interesting. Hopefully you can join us for that too. So now, if you are on our live event page and you've had a look around, you can put a note about yourself on the Google Doc. That then creates a post-it, something we do all the time at ODI Leeds so that people understand where they're going from and who's there. You can make comments in the chat and ask questions during the pre-record. And then at the end of the session, we'll be taking those questions and giving them to the speakers. And then if you go to the Docs Plus page, you can even have a look at trying to recreate the world of the pub afterwards, the serendipitous chat over coffee. Look at the instructions. It should be really easy to navigate how you use that. So what I'd like to do next is introduce Lieke Konijn from the Netherlands Embassy. She's been working on this project. And if you'd like to say hello, Lieke, over to you.
Hi, everybody. I can only hear myself, but really welcome to Northernlands too. We are really excited from the Dutch Embassy here in London to do this great event together with OD Leeds. Like last year, unfortunately not live today, this time, but online. We think that we are getting some really interesting subjects today on this event with some great speakers. I want to thank every speaker who is who is joining us today in this event, but especially I want to have a big thanks for OD Leeds for organizing this together with us. And I will leave it by that because I think that our speakers have much more interesting stuff to say than me. But have a great time and looking forward.
Welcome back. So now, before we start, we've got a couple of introductions. The first is from Brekje Schwakova, who is the acting, so what's she doing? She's the acting ambassador at the Kingdom of the Netherlands. And then we've got Mr. G, who's going to give you a bit of a wake up on a Monday morning.
Welcome everybody to Northernlands 2. I'm very happy to be welcomed by Brekje, the acting ambassador for the Kingdom of the Netherlands. My name's Paul Connell. And we'll have an introduction from Brekje, and then we've got a couple of questions that we're going to ask to set the scene for Northernlands 2. So over to you.
My name is Brekje Schwakova. I'm the acting ambassador of the Netherlands Embassy in the United Kingdom, and I'm very happy to be here with you today.
The first question I've got is, why is this subject important to the Netherlands?
Before I answer that question, Paul, let me say that I would like to thank you and through you, OD Leeds, for doing this with us. We're very happy to do that. And also to thank our speakers for devoting some time with us today. Coming to your question, why is this important to the Netherlands? I think in the last few months, we have all seen that data can be extremely important in finding a solution for large-scale medical crises. And as such, in the Netherlands, big data in healthcare and analyzing these data is a top priority. And one of the many things that we've learned during this crisis is how important it is to have reliable data at hand. So that is why I think it's very important for all of us to discuss this topic here today.
Fantastic. And having reliable data is definitely close to our heart here. So you probably see open data saves lives. So that's close to our hearts as well. So I'd like to ask you, what, in terms of policy, what does that mean for you and what are your thoughts?
Well, there's an ongoing debate in the Netherlands about who owns medical data. Is it you, the patient? Is it your healthcare provider? Is it your insurance provider? Or is it somebody else? And of course, privacy can be a big concern when we talk about open data. And considering the amount of data collected by various organizations, we must be vigilant when it comes to cyber attacks and breaches of privacy. In the Netherlands, we therefore believe that governments must work together with the private sector, but also with academia in these areas to take the measures that are needed. And
that plays straight across to a lot of the concerns and opportunities and also risks that we're identifying here in the UK.
Yes.
And in particular, so Dutch speakers, what role can they play as we try and navigate our way through this?
Well, we're really happy that we have the speakers that we have today and that they can share their stories, because they represent two important players in this discussion about open data in the health care sector. So research on the one hand, and the importance of opening up the data that come out of this research. And then the innovators and the entrepreneurs who are trying to find new ways of using these data in safe ways. And I think the European Go Fair initiative, in which Professor Mons, one of our speakers today, plays an important role, aims to implement the fair data principles, making data findable and accessible. And we need initiatives like this because, as I said before, we have to work together in this process of open data. And then, as concerns our second speaker, a startup like Core Life Analytics shows how important innovation is and that we need entrepreneurship to get innovations into the market so that everybody can use these innovations.
It wouldn't be ODI Leeds if we didn't ask a question like this. So, as a friend of the UK and with your unique insights, what would you like the North of England to do next and the UK to do next? And obviously, I'm really important in the North of England. So yeah, what should we do next?
Yeah, well, our two countries are, of course, closely linked, historically closely linked, and we will also continue to be closely linked, also into the future as from next year onwards, as North Sea neighbours. And as I said before, these solutions that we all need can only be found if we work together, and not only nationally, but certainly also internationally. And in the North of England, as it is, and with what it has, with organizations such as yourselves, but much broader than that as well. We hope that we can foster these links, and this seminar of today, or this webinar, is maybe one of the instruments we can use to do that.
Fantastic. And yeah, we'd love to do some more work with you and carry on, and we are definitely North Sea neighbours. The final part of this is just if there are some famous last words that you'd like to leave us with and what you'd like people to take away from the session.
Yeah, I think famous last words is a bit too much, but I can handle the takeaway part of your question. I think an important thing to emphasize is the availability of data, of course, for research, the reliability of these same data. In our search for solutions, of course, to save lives, we should be aware not to lose the importance of privacy, especially when it comes to medical data, very relevant nowadays. And we have to try to keep the international discussion open and constructive, as I just said. So that's maybe what I can bring to the audience as a takeaway.
I'd just like to finish off by thanking you for working with us on this. And I guess that if there's any questions from the audience during the sessions, that we can post them to you and your team. And if anyone wants to get in touch, they can either get in touch with us, or yourself, or Lika, or the rest of the Kingdom of the Netherlands ambassadorial team. So yeah, thank you.
Thank you, and thank you for doing this again. And yes, our team is ready for any help or questions that may arise out of this session. Thank you, Paul.
Thanks very much.
Thank you.
Hi, this is Mr. G. I want to give a big shout out to everyone in ODI Leeds. I guess we've got to do this conference remotely. It's a shame that I can't be there to meet you all. We had a great time last year, but I know that in the year to come, we'll all be meeting each other again. I want to give a big shout out to, everybody up north, man. I've been stuck down in London in isolation for so long. I've barely been up the road, let alone up the M1. So I want to give a big shout out to my people in Bradford, in Manchester, in Salford, in Leeds, in Sheffield, in Liverpool, the champions, and way, way, way up north to the Iron Brew crew in Scotland, Edinburgh, Aberdeen, Dundee, Fife. I want to give a big shout out to Huddersfield, to Middlesbrough, to Newcastle and Sunderland, the Tyne and Weir crew. I want to give a big shout out to my auntie in Harrogate and York, and last but not least, by the banks of the River Humber, I want to give a big shout out to Hull, because you are all northern stars shining high in those northern skies. And this all of you, and end of many norths. We can become consumed by, no matter how hard we multiply, to be another closed mind that simply adds to the subtraction of our times. Yet theories of accommodation require unlocking of conversations, adjusting for pause, pitch, and syntax to understand pronunciation, because the climates, they are a-changing. This is a land of many norths, a sky of many northern delights with northern stars to chart their course. For who should decide the laws, to procure the portals of our mind, beyond the point of no return, keep the beat for our own aim, and trick sheep, as karma records our orbiting voices drawn into data's gravity. Let's be responsible for our own northern stories, to be told with bolder honesty, so the intangible value that lies within us connects with broader synergy. So can I learn from expertise in Leeds? Can I keep in touch with the Dutch? There's always something refreshing going on in Yorkshire, because let's face it, London water sucks being radically open enough. It might seem that I'm hacking my own closed London system, but the first step towards knowledge is to admit your ignorance. Nobody knows everything. Everybody knows something. The future's calling. Just listen. Thank you. I hope you guys enjoy the rest of the conference. I've been Mr. G. Goodbye.
Welcome back. So, after that great start, what I'd like to do now is introduce our first pre-recorded conversation. It's myself, I'm Mark Farr, speaking with Ben Goldacre. We try to stay on topic, but as with three people who you know can talk, if you know them, we had a long conversation about health, open data, and what we're going to do next. So, enjoy.
Hi everyone, Northernlands 2. I'd like to say welcome to our so I guess you can say ODI Leeds is my fault. Tell us who you are and what you do.
Hi Paul, I'm the East Kent from Prescribing chair for analytics for Kent and Medway. I get involved in a whole range of other things with people like yourselves and Ben and the Health Foundation and others, but that's my day job.
Ben?
My name's Ben Goldacre. I trained as a doctor at Oxford and London, then trained in psychiatry at the Maudsley, trained in epidemiology, which is kind of applied medical statistics at London School of Hygiene. And then I came to Oxford 4 years ago to set up something called the Data Lab. And we're quite an odd group in the sense that we we're a truly mixed team of software developers, traders and clinicians, and we set out to build live, interactive, data-driven tools and services, as well as traditional academic research papers. And then I guess alongside that, I also do showing off stuff. So I wrote a column in The Guardian and wrote books called Bad Science and stuff like that.
Fantastic. So odd people showing off. I feel comfortable with that. That's good. So part of ODI leads strategy last year, and it's basically it's Mark's fault. So Mark came and spoke kindly at the Northernlands 1 conference, and he put that in my head about Open Data Saves Lives as something we could use to engage and take it to the health sector. But we didn't know how important it was. Something we started in 2019, we started work on it. And then since the start of this year with the pandemic, we've been doing a weekly session around data, health, and what we can do and share. And we've all been looking with all. Tell us about it. Tell us why it's so amazing.
Oh, thanks. All right. You have to promise me that we can talk about open prescribing at some point, because that is actual open data.
Yes.
Open safely is interesting because it's the absolute opposite. It is the most imaginable, and rightly so. It's individual patients' full electronic health record. So we've built a very highly secure and unprecedented health form that's running across the full primary care data, pseudonymized, of 40% of the population. So that's about 20-something million people. And in order to achieve that, we had kind of various goals. First up, we knew we couldn't do it in the traditional model of doing a large data extract and researchers downloading that onto their local hard drive and then running some Stata code or some R code in a kind of walled garden stats package. And we couldn't do that because that would be monstrously insecure, but it's also inefficient and expensive to ship 40 billion rows of data, which is what we're working across. So instead, we built a secure analytics platform inside the data center of the EHR vendors, TPP. So that's where the data already resides. And that brings a number of really important positive benefits. First of all, it's very cheap and efficient. You're not shipping 40 billion rows around the country, even down the fattest N3 pipe. It's still at the scale where you'd want to drive, well, I mean, you're not really allowed to drive around too much at the moment, but it's at the scale of data where in peacetime you'd stick a hard drive on the passenger seat to go and get it. Secondly, allows you access to in a pandemic instead of brings health, so you're always compliant environment. You're in a place where you've got logs of everything that happens, so you can be certain that everything's safe and secure, and you're not exposed to the risks of people doing re-identification data, which is what you get with big downloaded data.
Yeah.
Do you think everybody understands about the risks of re-identification attacks, or shall I explain them briefly?
You've got 47 seconds to do it.
All right. So take my if you want to find my wife in a GP electronic research data set, even though it's taken her name and her date of birth off, you just look for somebody who had twins in 2013, a baby in 2014, and the event codes moved from London to Oxford around about 2015. And then from publicly available information, you found my wife. Having then re-identified my wife in a pseudonymized data set, you then discover everything else that's attached, including all of chlamydia episodes after we got married, or nocturnal enuresis, bedwetting aged 14, or any of these other things, which do not apply to my wife, to be absolutely clear. But I'm just giving you examples of, first of all, how easy it is to identify somebody, and also the catastrophe of what you can discover. Go beyond just having because the most disclosive event, one row ID, on this date at this time had a blood pressure test, 140 systolic over 100 over 70 diastolic. Those kinds of single events. Now, when you're doing epidemiology research, you don't necessarily need all of that very granular detail. For example, you might want to build a data set that's one row per patient rather than one row per event. And for each patient, you might want to say, create a variable that's one if they've had a high blood pressure last 6 if they've not. We didn't want to create a world in which researchers had the full power of a versatile against the most disclosive data. So instead, we've built a platform where researchers have to do that. Never. So instead, you description, and that's essentially just a very stripped down representation of the SQL query that you want to do. And then that runs against the real data to extract your true data set, and then you can run your Stata code or your R code or whatever. And there's lots of really clever fancy bits in between there. So for example, we wanted to push forward from a world in which people do electronic health records research in silos, for the most part never sharing their code lists, which is what you'd use to identify outcome variables or drug exposures or disease exposures, never sharing code. We wanted to push working, but for people to do the right thing. So we built Open Safely in that image, and so run code against the platform or define a cohort. You have to do that by writing it in a GitHub repo. You can clone a template right now, and if anybody wants to at home, you can go to Open Safely's GitHub that template and you can build your own study definition. Then we're also trying to bring sort of computational data science techniques into being the norm for EHR research. So for example, you write your study definition and you don't just say, I want this outcome variable to be, have you got high blood pressure or not? You also say, I want this outcome variable to be high blood pressure using the following code lists in the following date range, 0. And I'm expecting the prevalence of that to be population. Automatically genetic data of exposure and outcome variables. It's just a simulated data set randomly generated. Develop your Stata or R code and it will check on GitHub that it passes tests. Then you push it to run on the real data and then you get your summary results out. And two people manually look at them and then they get released out so that the rest of the team can take a look. And it's all built in a glorious, and I cannot tell you how much fun, bordering on a love affair between our teams actually. And it feels to me like a massively missed opportunity to get EHR software developers working closely with it. It's a sort of real no-brainer. I feel like it's, as with a lot of things during COVID, and I hope we sort of can talk about this in more detail later, it's been great, the pace picking up and some unhelpful barriers cautiously and thoughtfully worked around during the period of COVID.
So Mark, you massive hospital, been like in a massive hospital dealing with?
I mean, I thought like you, it was sort of be beholden on me to do kind of first line research. So I went to a place in Austria where everybody caught COVID, and then but the weird thing for us is that, because a lot of people will say to situations like this, well, hospitals, they sort of do that a lot. You know, we're ready for planes to fly into bridges and, you know, natural disasters and oil spills and all. Quite good at putting up an operational control centre, producing gold command and silver command and bronze command and all those sorts of things. Nothing else we've ever seen. And a lot of the issues for me, and I agree with a lot of what Ben said, and I'll give you some examples in a minute of things that I think are really positive and have kind of accelerated. To receive national modelling advice and then work out really quickly that it didn't really work for us, so then had to stand up local modelling resource models that were us that didn't take sort of national averages and just apply them crudely down into Kent. So we had a whole stream of that started really quickly. Now, are we going to put hospital a kind of a Nightingale for Kent, as it were, and how many and where would we get them from? And it all felt really, really difficult. And we thought we were going to have hundreds and hundreds of ITU beds, and as of today, I think we've got less than 40 people in an ITU bed on a ventilator. So we converted theatres into ITUs, which we're now converting back the other way. And it's not out of May, and so new that we've had to kind of work in such an agile modelling. I agree with Ben that we've got some stuff done that's been really positive. For almost 2 years, I've been trying to get the NHS to agree to share data to analyse intimate partner violence. I felt really strongly about this, and there was a lot of reporting through April in the Sunday papers about domestic abuse and calls to sports centres and so on. And we managed to make the case that it's reasonable to link these two data sets together, done securely, done appropriately, along similar but different to what Ben's done. And we got that agreement. We've got that agreement for 3 out of the 4 hospitals in Kent within a week. And I'm going to try and knock the last one over soon. And we've had some initial results back from the police, just at a kind of linking 2 files together level before we even start trying to do any sort of predictive modelling. And it looked really, really powerful, the data. So getting stuff done and getting it done quickly and sensitively, I completely agree with Ben. That's been really key for us.
Yeah. And we've been talking, one of the concepts is how do we now get that, and how do we write it up? So you're doing it in Kent. How does that happen in Carlisle? Just us all getting involved, and it links to your point, Ben, of forcing people to be open in how they access the data, how they access your work. Open data saves lives is about. So I guess we're talking about getting people to use the web. So when you write a blog post about that, Mark, and we put the governance framework around it, and you write a little story blog and a technical blog, and we put the code on GitHub, how do we get that deployed in Carlisle without having to spend a load of money on consultants? Which that's the dream, really.
I mean, we've put a lot of stuff out publicly. So all of the joint data control agreements that we've had that have been through 25 lawyers, everything through the committee I chair is all publicly available. So we've set up new local data sets for COVID, not because the regulators asked us to, but because it seemed like a sensible thing to do. We've ourselves data dictionaries for all of that. We've got through the webinars, we've got people kind of adopting that and giving us advice on where is the latest decent list of where care homes are, because that was something we had to look at really urgently, really quickly, and just getting UPR would have just been turgid and taken months and months, and we kind of got that done quite quickly. I
think it's the best, by the way, Mark. Did you get a CQC care homes list matched to UPRN?
Yes, I think that was, and again, that was through just contacts of Paul. We got to that list much quicker than we would have done historically. So that's quite useful, that published data that the CQC do.
Well, we went through geography, It Saves Lives, in the session, and it was it's how the UK has managed to shoot itself in the foot about geography and how the...
No, I agree. I think there's some really interesting cultural stuff in there as well. For example, a lot of anxiety and lack of clarity around licensing for things like geodata, and that's almost worse than a hard no to a given data set, in particular because it lets people who are being miserly off the hook because they can live in the shadows, but also it creates anxiety where one individual in an organisation, he says, look, I've looked at the licence, it's fine, we can reuse this, it's okay, don't worry about it. And their boss, who's a generalist and legitimately across, goes, oh God, I know, you know, you better go and get that reviewed by legal. And then reviewed by legal means it's in a huge queue, and reviewed by legal is expensive and slow and all that.
No, then yes, isn't it?
We've had all that with the IG. We could have just rolled over on the IG on the police thing. And the thing I always say, you know, would be famous last words, but if you kind of go up into the legality of it and the ICO, it's about if the language as you become more actually becomes more loose. You were defending court and would help you sleep easy in your bed. So trying to address the risk of domestic abuse during lockdown feels like a good thing to do. I'm not building a mailing list for a drug company or anything. I feel really confident that that's a good thing to do. But it's really easy in law to say it's all a bit difficult actually, and we need to come up with a way of consenting every single patient before we do it. You know, we're trying to get the British Red Cross at the moment to look after some of the patients that come into our emergency department who've got quite chaotic lives, and they're definitely coming from a good place to try and do it. But I've had to push and push and push for us to do that, and we're now doing it because in law you kind of drift into were they able to consent well enough for us to record that they'd consented enough? And I think that's part of what Open Data Saves Lives is to give a kind of defense against this kind of lazy privacy concern angle.
I think good people do bad things for the right reasons, and I think there has actually been a lot of sloppiness around IG over the years. I mean, the thing that I actually find really dispiriting is that there are a lot of projects out there which are, to my mind, monstrously insecure by design, but ring binders filled to overflowing with signed off under IG. And actually, it's really, you know, it's interesting. It ways you can have bad IG that blocks good things. You can have bad IG things. I do think that again, there's a really interesting cultural point here, which is first during this period of turbulence, and it's not anarchy, it's flexibility. There's a lot of really good stuff. People going, okay, I'm going to pick up the phone. I'm going to talk to the person in the local authority or the hospital who normally I'd have to go through 15 different layers to get. All right, hi, is that Barbara? I've got an idea. Can we do a thing?
Yeah.
And what I'm really hoping is that I think there's a lot of enthusiasm in the air for retaining of the new norms that have arisen during COVID in the post-COVID era. And I think it will be really powerful if that happens. I think the other thing that I'm really hoping to see is, and this really speaks around public goods, around incentivizing with open data and open source tools. I'm really hoping to see successful delivery, not just praise or some kind of monstrously complicated, like, oh, you're a pathfinder and now we're going to work out how to deploy with an innovation deployment opportunity grant that costs more in person time to ask for it than it, right? What I'm hoping we will see is people going, okay, here's a group of people who delivered something that's useful, and we're going to take the approach of GDS and the best of sort of digital innovation in you resource teams, not single pieces of work. And you go, here's a bunch of people who did something really useful. Let's resource them, because fundamentally the big challenge that I think government and the health service face is you're trying a whole bunch of new behaviours around technical skills happening out in government in the health service. It's really difficult to do that. You're struggling uphill against people having line managers who are generalists who don't understand the technical work that their immediate reports are engaged in, and all of that. one of the best things you can do, as well as trying to create the perfect job descriptions and the perfect formal job ladder, and you could also say, all right, we found people who are doing something useful out in the system. They're definitely delivering because they've got a proven track record of shipping outputs that worked. Now let's resource them so that they can be, number one, taken off any jobs that don't use the technical skills they have that we want to see exploding across the system. Let's resource them so that other people can go and sit next to them and watch how they work and learn from them so that they can spread. And let's resource them to either produce essentially propaganda or educational materials, either themselves or with overdue a bit of proper knowledge management. There are professions who unfortunately don't have a good name. They've got names like librarians or information scientists, but they're not putting books back on shelves. Like, there are people who've given a great deal of thought into how to curate complex technical knowledge in a commons of knowledge to help people find the information they need at the right time, to help stop good ideas getting lost and all of that.
When I was allowed to go to the pub, I used to get drunk and rant about that sort of stuff.
All I'm asking for is a coherent information architecture.
Well, do you know what? There's a thing called the web. You know?
I've heard of that. Yeah.
And if you put things on the web, people can find it. You know, and imagine if that health architecture, you said every project should have three things, which is a story blog, which describes what it is, a technical blog, which says how we did it, and then a repo with the data and code, and you link it all. And then you said, well, actually, I can then find it on the web, and then I can look it up. But
well, I mean, it links to about where one of the things we found under COVID is that we've been asked to give loads and loads of people loads of data all the time, but we never get any of it back. And
Yes.
and if you and I ran neighbouring, which would be really helpful. It'd be really helpful for Maidstone if your numbers are going up.
Well,
so we've had to create all that ourselves.
There's also something really important, I think, Mark, around reciprocality. So over a load of data, you should expect to see the thing that it is used for coming back to you.
Yes.
Makes it clear to you
And not locked down again. Not locked down on an NHS England Tableau dashboard. So I mean, joking aside, if you had a principle where every time you sent some data, a sit rep or else is back, there's no one any of that, but it'd be really knew exactly how many people in every school in Ashford had been tested, and what our rates were as we drifted into Maidstone or we went across into. It'd be really simple to do. So we've done some really good stuff locally without being told or asked, to just link a load of our data together and to create new data sets that we're all sharing in the open. Some of Paul's tools, hopefully. But it's frustrating that you're involved in this machine into a centre, and even if it just went to people like you, that would be a start. But if it kind of came promptly back to us as we sent it.
So Open Prescribing, which we built in my group in Oxford, is another very good example of that. So Open Prescribing is our service that lets any interested person go and see individual GP practices prescribing down to the level of individual prescriptions, month by month, individual practice level. And Open Prescribing now has 135,000 unique users a year, 15 or so thousand unique users a month. It's got thousands of people subscribing to alert service that's driven off fancy statistical process control techniques under the bonnet, but which is nice and friendly and easy to when you subscribe. And we did that very deliberately because I've worked with EHR data in the past, rich, disclosive, but pseudonymized, very detailed event level data. I wanted to start building live interactive tools and services like Open Safely, but we started with Open Prescribing without being shackled and slowed by the phenomenal cost and permissions and everything, which is legitimately around closed data. So that was the only way that we could possibly have got our group up and running and and using our collaborative approaches and freely sharing code on GitHub, where we've now got 45,000 lines of code in total. Well, I think more relevantly, 1,000 issues open and closed. So working with that open data, first up, it's probably the richest health data set that's ever been shared as open data. We have published studies showing that in places where open prescribing is used, that prescribing improves. We've got huge numbers of examples of really important signals that we've detected on risk, quality, and cost effective that simply would never have been discovered anyway. They were certainly never detected by the people employed by NHS Business Services Authority or NHS England to analyse this data. And why should they be? So that's not a criticism of those organisations, but people working behind closed doors, but also in limited numbers, obviously all of the perfect answers for every possible user group, for every possible analytic idea, on every possible aspect of every possible data set. It's just ludicrous to ever imagine that that's how creative analytics could possibly work. There's also, I think, something really interesting and political here, which is around where data is and isn't disclosed. So, Mark, you work in an NHS trust, a hospital. Hospitals are quite large and powerful organisations. And there's a really interesting historical anomaly, which is that for GP level data, for practice level data, it's basically all published and shared as open data sets. Compare that with hospitals. No hospital prescribing data, well, medicines usage data, because e-prescribing hasn't really had much, no data is shared as open data. And I'm happy to talk about the reasons behind that. We've got a paper hopefully coming on that in the BMJC. All of the model hospital data, the flagship variation in care national analytics program, not a single one of the hospital is shared. Now that would be much, much less disclosive. And I think it's really, really interesting to think, why is GP data always shared as open data, which then creates this real ecosystem of people doing collaborative analytics to help, and also done in a really positive spirit. Like we almost never see anyone misusing open prescribing in a childish way. We never see people going, is this the worst GP in Kent? In fact, we've never seen that. But it's really interesting. GP data shared, hospital data not. And I do wonder if that's a function of their political weight and their size.
So we're rabbiting on, and what I'd like to do...
I've got to go. Yes.
Yeah, you've got to go. But let's finish on something positive. So we, myself and Mark, we're launching Open Data Saves Lives as a bit more of a thing this year. And exactly that point is had to help people do more and also kill reports. So rather than writing reports and presentation of PowerPoints, build stuff that fixes stuff. So that's what ODL Leads is doing. So in Kent, Mark, what are you doing that's sort of positive and out of all of this?
Well, I'm still reveling in my success with the police, but I've also got I've got Joint Data Control, which is a GDPR function, signed up across the whole region. So we've got 2 million people, 20 odd NHS organisations all signed up, no politics, network, ships. Everything we're doing is published openly. So that's really positive. And it looks like we've got some big research bits that we can announce soon to carry on building a linked data set at a lower level of depth. You can just linking sus data, it's not that interesting. So it's really exciting. We've got medical school opening. We're going to open a data lab with the university and the medical school. So I'm really excited about that.
Fantastic. How about you, Ben? What's next?
We're expanding Open Safely, and we're expanding it in various interesting directions. I'm really, really interested in seeing a better commons of knowledge around operational research. And this is something that me and Mark have talked about a lot. In fact, we've got a paper coming out in Journal of the Royal Society of Medicine, which is around how to kind of build make operational research again. The Lancet used to publish audits in the 80s. I mean, it was a normal thing, and behind closed doors, and there are pockets of greatness and pockets of drudgery and manual labor in Excel. We need to make it a thing which has a commons of knowledge, a shelf full of textbooks and courses, rather than just go and sit next to Mark Farr for a while and you'll pick it up.
Well, my aim is that that's something that people who are 20 want to do when they come out of a university with a good maths degree. That's literally what I'm trying to do. So I'm going around university saying, this is cool. You can meet people like Ben and Paul.
Jesus, I don't know, man.
So on that bombshell, I'd like to say thanks very much. It's been amazing. And goodbye from Northernlands 2. Thank you, Mark.
Thanks, Paul.
See you soon.
I really enjoyed that. There is an unedited version that goes on for about an hour, which, if you are a real health tech nerd and you want to listen to myself, Mark, and Ben go even a little bit even more off-piste, you can listen to us. So this is a Q&A. I've got Mark Farr here with me, who's going to take the questions. We've got the first question comes from Gemma Scryer, I think, and it's, how can we ensure the third sector is supported to contribute to open data and be a bigger part of delivery? So, Mark, you've got some thoughts on that, haven't you?
Yeah, hi, Paul. Really interesting. I think one of the things we've spoken about in the past is kind of different tracks of either getting the data or getting the permission to get the data. And I think some people start with the latter too often. And I would encourage people to just get used to moving data. So keep it quite high level and quite anodyne if you want to start with. Make sure it's anonymous, regional instead of local and so on. But just get used to flowing the data, get used to using the tools that Paul and the team can link you in with. And then twin track, play the ethics game and make sure you can get permission. And I think in the third sector, a bit like in industry, actually, it's a lot easier actually to consent people. So you can do a lot of work where you consent very specific cohorts of patients and get them used to doing this. There's some industry partners that work with me and GP data, and they consent all their patients. In return, they get access to their medical record on their phone, but they consent them to use them in research and regional profiling, tracking outbreak of COVID and so on. So do two things at the same time. Don't do one instead of the other. Get the data flowing, link in with Paul's team, and then reach out to people like Paul and me to help with the information governance side of it.
Thanks, Mark. There's a couple of questions for Ben, which I think we might be able to take, but there's a question around are students able to work on the data? I don't think so at the moment, but we'll watch this space. And then is open prescribing just for England only? I don't know the answer to that, but I suspect it is because the way in which the NHS is structured. But we'll find out and come back to you and put a post in the chat, and we'll follow up. I've got a final question for Mark. So what happens next with Open Data Saves Lives?
Yeah, well, I mean, interesting, because you kindly invited me to your gig a year or so ago, and we spoke and said things that were inappropriate and so on. And then COVID came along, and it just proved without a doubt that some stuff we were talking about 18 months ago has to happen now. And you can see just in the United Kingdom that different parts of it are much cuter about how they use data and how they float around. 20 miles across the sea from where I live in Kent, France are much better at producing local data, tracking infection rates, publishing it locally, trusting the public to actually make their own judgment, not patronising them into not allowing data out there. So out of an idea you and I had a little while ago, I think we're at a point now where we do something more formal, and we're talking to people like the Health Foundation. We're talking to some industry sponsors about forming a new organisation called Open Data Saves Lives to push this agenda. I think we've got 4 things we're really interested in. It's kind of boiled down to 4 big ingredients. And the first one, they're all as kind of hashtags. The first one is give the data back. So if you work in the NHS, you are involved in an industry of sending data into a machine at the centre, and you never get the data back from the trust down the road, because that would be quite useful to put next to yours, and you could create a benchmark. So we have to get the data back. And the principle is any data I send, I should get back the same data for every other trust in the country, because it's very rarely patient identifiable, and it's very rarely sensitive enough that you should worry about that. So we need to get the data back. The second one, and to that point about information governance, we're calling it save lives, not data. So we've recently got permission to link police data to health data to track the risk around domestic abuse during lockdown. And it's COVID and lockdown which have helped free that information governance obstacle. Some people have made some quite brave decisions so that we can get on with some of that. And the early results from linking crudely files of people who hit their wives and files of wives who've been hit together, we hope that we can intervene in intimate partner violence earlier. So that's save lives, not data. So building the kind of ethics case for doing this and getting on with it. The third one might need a change of name, but it's currently smash the data controllers. There are some quite old-fashioned business models out there with people being quite parochial about data, where it used to make a business case for them, but that the data, particularly about geography and all kinds of things, just needs to be out in the public much more now, and just needs to be funded in a different way. And then the fourth one that we're quite interested in is something quite close to your and my heart, Paul, because we sort of holidayed and got COVID and shared our loss of taste. And, you know, we've created a very rich patient sharing application just within WhatsApp of symptoms day by day. And all the sort of emerging research shows that about 70 or 80% of people are well up for sharing their data to improve the greater good. So I've got a bad back. If Paul had a bad back, we'd be very open about sharing the results of our MRIs, comparing notes on whether to have a laminectomy or not. It's not a sensitive operation. We're not embarrassed about it. It just reflects our age and that we've played too much football and done too much skiing and so on. And it's really difficult to go and find out, get advice about what surgery to have, what you should be eating, all sorts of things. And there's this movement growing called the quantified self, where people are quite up for sharing an awful lot of data from their Apple Watch or their Fitbit or their Garmin and, you know, or their MyFitnessPal. But there isn't a good mechanism for easily doing that. So it just exists in little silos called Strava and other places. And I think, and some of these technology providers are well up for helping us. But I think that's something we could do. There's some good symptom tracking stuff going on around COVID. And COVID's just given a lot, as bad as it's given some really, really good examples of how you can actually move data around, share it in much more real time, learn from each other, you know, be reassured that the metallic taste in your mouth is a similar sensation to a group of friends. So you're not bombarding 111, turning up at an A&E. It's just some massive opportunities. And I think open data saves lives has become so big now that we need to kind of get on with it, get some money behind it, employ some people, and just crack on. So it's really exciting, as you know, I feel.
Yeah. Thanks, Mark. That's amazing. And now, quite serendipitously, almost like we planned it, we've got Emma Vesterson from the Health Foundation, who's going to talk to us about why collaboration and working in the open is important in health and beyond. So thanks, Mark. On to the next one. Thanks very much. Cheers.
Hi, my name is Emma Vesterson, and I'm a senior data analyst at the Health Foundation. I'm here to share some of the work we're doing about open analytics at the Health Foundation. So the Health Foundation is an independent charity committed to bringing about better health and healthcare for people in the UK. And I'm part of the data analytics team at the Health Foundation. And over the last year or so, we've done some pretty intense work around making our analysis more reproducible and open. So there are big challenges facing health and healthcare in the UK, and this was true even before COVID happened. But at the same time, we're seeing some rapid innovation in the use of analytics and data-driven tech in the health and care sector. And this carries huge potential to address some of these challenges, but it does also carry quite substantial risks if we're not careful with how it's implemented. And our aim is to ensure that data analytics has a positive impact on the UK's health. And we're working for a future where everyone's health and care benefits from analytics and data-driven technology. So how are we doing this? So we want data analytics to have a positive impact on the UK's health. And there are several ways in which we're working to achieve this. So we want to have innovations in data that tackle some of the big challenges facing the sector. But we also want to influence the national conversation and be an independent voice, an expert voice on national policy and system design. We offer funding and support for innovative work because we want to support better analytical capability. And we want to help create networks, communities, and partnerships. So what does open analytics mean to us at the Health Foundation? So we're very committed to being transparent and open when doing analysis because we want people to be able to look at what we've done and ask any questions or pose any challenges. So we want to actively champion good analytical practice across the sector and spread and share what we know. So we started doing this by publishing our code on GitHub around a year ago, and last September we had kind of a mini launch of our own GitHub page. So we now make all of our analysis code public by default, even when it's work in progress, and we're working towards exclusively using only open source languages. But we don't think that sharing code is enough. So each repo on our GitHub has got a description of what the project sets out to do, information about the data source, whether or not you can access it, which you should be able to do if it's open data, and what else you need to do to reproduce our analysis, so other things you might install or packages you need. So for us, working openly is an ongoing project, and we're kind of using our own team to experiment a bit and test the new and more open ways of working, which sometimes can be a bit challenging, but we feel like we want to understand how we can work openly as a team and then start talking to other people about how to do it and advice on what they can do. So in addition to putting things on GitHub, we're also sharing what we learned along the way and how we overcame some of the barriers to working more openly. So we published a blog post on Medium where we described the process we went through as a team to launch our public GitHub account and provided kind of a step-by-step guide to how others can do the same thing. So the problems we're working on kind of are big and they really require more of a collaborative approach to actually be tackled. And we believe that transparency and working openly and reproducibly are essential to achieving this. And we see open coding and open data as good analytical practice. There are so many benefits of working openly. So first of all, sharing our code helps us avoid duplicating work within the team, but it also allows other researchers and analysts to be able to review and validate and reuse our code. And this is something we've definitely done through COVID, where I know I use code from an analyst in Nottingham, and I know that other people have used our code. It also makes it a lot easier to share our code and our work internally, so we know what our colleagues are up to, and we can celebrate progress. And it makes it a lot easier to credit people both internally and externally. I think it also openness also just makes for better science. So there's a permanent record of the analysis that we've done, and it's reproducible. I think also personally, knowing that my code is going on GitHub makes me go that extra mile, because I just make sure that there are enough comments to explain what the code is doing, and I haven't left things in there that I don't want anymore. And this makes it easier for other people when they use my code, but it also makes it a lot easier for future me to go back to a project. So unsurprisingly, COVID-19 has changed the way we work at the Health Foundation, but actually we realised that as we're all working remotely, working openly has become even more important. We have done a lot of reactive work related to the pandemic using open data, and this has allowed us to inform the national policy debate and highlight the effect of COVID on vulnerable groups such as care home residents. And you can see a few of the examples of some charts that we've created using open data at the Health Foundation. So even though it was great to use open data for this analysis, there were some challenges with using open data. And sometimes we were slightly limited in what we could do. And some of those problems were related to the data itself. So it might not have been granular enough. So we would, for example, not often be able to look at both sex and age at the same time. And sometimes the data wasn't updated as frequently as we would have liked. So we would produce some analysis, and even if when we knew that more data would bring value to the discussion, we weren't able to do that. There were also slightly more technical issues that we had. So quite often, open data isn't shared in a machine readable format, meaning that there might be multiple tables in one spreadsheet, or there will be random text in places where a computer wouldn't expect that to be text. It happened a few times that I went to a website to download a new version of a data set and it had just disappeared and it was being published somewhere else. And this, as an analyst, makes it really hard to build a good workflow because the data is just no longer there, and any work you've done to put in kind of automatic downloads for anything is gone when there's no consistency. It also obviously happened that the data changed format, which again poses a big problem for an analyst because you need to go back and check your code. But we do think that the people who are sharing data want us to use it. But especially when things are moving quickly, it's quite easy to not share data in the maybe best way. So we wrote a blog with some thoughts on how to collaborate in a time of crisis and how to share data in a time of crisis, with a focus on how to make sure that if you're sharing something that people can actually use it. So we wrote our own blog, but we also know that there's a lot of good work out there on how to share open data. So ODI Leads has got some open data tips, the Government Statistical Service has got some excellent resources, and the Turing Way, which is a slightly more academic resource, has got excellent advice on how to make your research reproducible. So a lot of the call of the action is coming from analysts to kind of improve how we do analysis, but we also think that data controllers could really, really help speed up the work and spread open working. So from a position as someone who actually does this kind of work, a lot of us use Data Managers Digital and ONS, and it would just be really, really good if, we could see some processing code, some reference data and some metadata, as this would really help us with our work, but also being able to be signposted to the other people writing code for the data that you're looking at would be really useful. So I've focused quite a lot on code and technology today, but we don't think that's enough to collaborate effectively. So based on the work that we've done internally to work more openly, but also some of the work that we do to support analysts in the sector, we have a few things that we think might be stopping people from working openly. And we think that the first thing you can do is ask yourself, why is my team not working openly? And we think that a big factor is buy-in from management. Analysts really need to feel safe sharing data, and often that needs to come from somewhere higher up to make sure that there's that support. There also needs to be support for the extra work during setup, because when you start working openly, at the beginning it is a bit of extra work, but it's really worth it, and I think in the long run you're probably saving time. But also having a community is really important. So knowing that more people are working the same way provides some reassurance that even though it's hard, this is a good thing to do. So if you want to start working more openly, you need to acknowledge that working this way might require a culture change. So what do we do to support analysts? So I've talked a lot about the analysis that we've done, but a large chunk of the work that we do is actually focused on supporting analysts working in the health and social care sector. So far, we've funded 43 projects for 4 different rounds. It's something that we call Advancing Applied Analytics. And we've had a lot of workshops with these award holders So the support doesn't stop with the funding. We have these workshops, and people can come together and troubleshoot issues that they've encountered over the course of their projects. When COVID happened, we also set up a repository of resources for analysts working to support health and care during the COVID-19 pandemic. And there we're trying to share different solutions that people have suggested that are kind of more open. So we have a few projects that we just want to highlight. So with probably the biggest one being the NHSR community, which was, I think, probably our big first investment in this area. And it's an initiative that aims to build a community of analysts in the NHS to spread the use of the R language. And through this, we know that there's interest in the system to work more openly. And we're hoping that our funding programme encourages an open approach to both sharing methodology and code. So I want to end by focusing on where we're going next and a bit of a call for action. So the last few months, we've seen some really remarkable innovation with health data, but we haven't seen the same thing in social care. And this is despite how hard the pandemic has hit the social care sector. So we're doing a few things. First of all, we're teaming up with Future Care Capital to do some work around social care. We really think that open analytics will play a key role in sharing the learning of these projects. And we're therefore launching a funding programme in August for projects that can address barriers to analytical capability in social care. So to watch this space, and if you think you can do some good work in this area, please join us. Thank you.
Hi.
Thanks very much for that. That was amazing. We've got a couple of questions, so thanks for joining us. There's a first question, which again is about the third sector. So I'd like you to start. Do we have any examples of small charities working with health data and vice versa?
So I don't really know of any specific charities, but I think DataKind UK is a very good place to start. Yeah, because they do some really good work working with small charities.
I'd agree with that. They're brilliant, and they do offer support, and they offer internships, and there's a whole load of things around that. So look up DataKind UK if you'd like to follow up on that. And then I've got a question for you, Emma. So we've been doing this for over 6 years now at ODI Leeds, and I guess we've taken the blue pill of being open, but the world of data and openness is smashing into health right now, particularly around COVID. Are there some specific things that we need to do next to help people be more open?
So I think it's a lot about culture. So I think it's what people usually say when you talk about working more openly is that they're scared that they'll make a mistake and someone will notice, or I think more that someone will notice their mistakes rather than actually making it. But I think it's embracing that you need to be careful, but it's okay to make mistakes, but also realizing that if someone points something out, that means you can fix it, and that mistake would have been there even if it was hidden behind 5 firewalls. So I think allowing people to make mistakes and knowing that's okay.
That's exactly what ODI Leeds does, and I think the reason we've been able to move so fast and quickly on some of our projects is because we accept that we might get things wrong or slightly wrong, but that's the reason for releasing early and often, is that people can tell us quickly, so we fix it quickly. So we've made progress in a matter of weeks and months, which would normally have taken years to make, because we're happy and we're comfortable about doing that. So I think our job and your job might be giving people permission to do that and be more open. And if they get it wrong, they could blame us, and we can help them do that.
Yeah, exactly.
Cool. So thanks for that. What we're going to do now is, like a normal conference, we're going to have some tea and coffee. So we've got, it's now 11:09. We're going to give ourselves 6 minutes, so back at 11:15 for the next talks. Thanks very much, Emma, and thanks everyone.
Perfect. Thank you.
Cheers.
Yes. Bye.
Welcome back, everyone. Hopefully you've had a nice cup of tea or a coffee, and you might have looked in the chat and also in the Docs Plus document to make some new friends. So we've got the second part of Open Data Saves Lives at the Northernlands. We've got 3 great talks, one from Professor Baron Mons, Jenny Tennyson from ODI HQ, and David Egan, again from the Netherlands, one of our North Sea neighbours. So next up, Professor Baron Mons, who's founded GoFair, president of CoData, and he's going to share the details of the FAIR project over in the Netherlands.
Good day to everyone. Sorry that I cannot be there in person, but I would like to tell you today about the VODAN, the virus outbreak data network that we are running in times of crisis. And I would like to explain that the title is Open Data Saves Lives. I would like to argue, coming back to it later in this presentation, that FAIR, not only open data saves lives. One of the major issues we are dealing with in Corona is that the data that we need to get our answers cannot be open. They are patient data. They don't leave the country, certainly not in a highly politicized environment as now with COVID-19. So we need to work with data that are findable, accessible, interoperable, and reusable, but not necessarily open. And I will hope to convince you in this talk that this is the way to go. So, first of all, we have set up this virus outbreak data network, VODAN, and it is based on so-called FAIR data points as a service for data-driven research, distributed analytics. It is a pressure cooker use case for our approach because now everybody is panicking, but of course we can wait for the other outbreaks to come. So we don't do this just for COVID, we do it for the general virus, in this case, outbreaks. And what you see here is that 4 major international organizations, CoData, GoFair, RDA, and the World Data System. I'm not going to explain all of them right here, but you can look this all up. This is on the web. They have made a joint statement that confirms this statement I made in the beginning, that we cannot have a central database, we cannot have all the data open, so we have to find additional and alternative methods to do this. And our approach is as follows. We see a globally distributed network of FAIR data points from China to the US and Africa. Already several have been installed in Africa, actually under the VODAN project. That's the green dots. And the orange dots are stations with lots of established knowledge and reference data, biomedical knowledge, to interpret what we see in the green dots. So that is the basic dream, and maybe some of you would say, whoa, this is way out there. No, this is running in a small setting already, and this is also our belief of how, for example, the European Open Science Cloud or any other system should work. And to make this happen, we have to construct everything on the web and make it understandable for machines. So I now summarize FAIR as the machine knows what I mean, which will now also address this openness versus fairness. So when you have any FAIR digital record, if it's a single identifier, an assertion, a graph, a database, whatever, spreadsheet, and it's a digital object, it needs to be a FAIR digital object, which means a number of things. Let's not go into the details at the bottom of this slide, that it needs to have a globally unique, persistent, and resolvable identifier that the computer knows where it is. It needs metadata and it points to a resource. All these things are a bit technical, but at the highest level, the computer needs to know what is this. So it needs to have a type. Is this a triple? Is this a graph? Is this a database, an Excel sheet? Based on that, it can answer question 2 on the left-hand side. What can I technically do with this digital object? And then the third question is, what am I allowed to do? And here we get the link to open. because it may find in the metadata of the fair digital object that this data is highly relevant for me, but I'm a company and of a virtual machine from a company in our setting, and I'm not allowed to see these data, and others are. That's not the same as open, but it's still fair. So the idea of the personal health train that we are setting up in the Netherlands, and also of the trusted world of Corona hotels here on the right-hand side, is essentially that a train, which is a virtual machine, a learning algorithm or analytics algorithm, visits data stations that have fair data. It does not take any of the original patient data with it. It can also visit an established data station to interpret the data, but the only thing it takes with it is, for example, how many people in your hospital that went into the intensive care unit had an elevated prostaglandin E or whatever cytokine IL-6 level. And it collects all these data without ever having access to the patient data themselves. So this hospital, let's say it's us in LUMC, we say we had 15 patients. Yes, all of them had increased IL-6 and prostaglandin E. In the end, that gives you that the idea you were coming in with, that's why it's analytics, not necessarily learning, because you have a hypothesis. You can do that without ever taking any of the data outside their safe silos, which is critical for the crisis that we face today. How we do this is that applications, data sources, and the necessary infrastructure like compute power is distributed all over the world. We need to facilitate human-to-machine connections, machine-to-human and machine-to-machine. It should be based on the fair guiding principles, and then it can work, because then we can give each application fair metadata. So it can instruct any computer, I'm looking for A, B, and C. Let's say I'm looking for CT scans of COVID patients. They have to be in DICOM format. Then it is searched on the metadata, and you say, can I visit with my algorithm to learn on these pictures whether a particular structure that I always seem to associate with severe disease is in the pictures or not. You don't have to bring the pictures together. Then you can construct beautiful things like this. And of course, people that have constructed these pictures, like the mutations of the virus, the maps, or even this thing that came recently about all the genes that may be involved in susceptibility of people for COVID. Some lucky few people have a lot of data at their hands in the UK Biobank or wherever, like this Precision Life picture, and they can make these kind of pictures, but you need a lot of data. And in most cases, this is totally impossible. And we have lost a lot of lives because it took far too long before we had enough data to see the pattern that now gives us the impression that we probably did not treat the first wave of severe patients correctly. So what we did, based on fair data, but we had to painstakingly find them in publications. You know, there's 250 publications per day coming out on COVID. So it's a crazy pandemonium of information here. Then we have case report forms, like this is the WHO case report form, measurements. We measure 96 cytokines in LUMC at the moment for every patient that is severe. You have apps, self-reporting. All these data, we call them real world observations. We need them to see what's really happening. Then you have all kinds of hypotheses here on the right-hand side in the yellow panel. We know which viral proteins interact with the human protein, proteome, meanwhile. We have the receptors that the virus uses and that can be disturbed. We know that it can cause a cytokine storm by disturbing also the ROS system. You get thrombosis and vascular leakage, and we can have any other hypothesis. You want to test those, but you can only do it with the computer because all the pictures I showed you before can only be made and interpreted for pattern recognition by computers. So the data needs to be machine readable. With a Dutch company, we can make a disease model for any of those hypotheses. And now we can actually start rationalizing drugs or interventions and see if we add this drug to this model, what is likely to happen. And we can do that for many drugs. And here in Leiden, that's just one example, but in other data hotels, as we now call them, you would see the same data, but you may have other wet lab possibilities to test things. And in Leiden, we can actually pass the plasma of severe patients versus controls through microvessels that are intact with endothelial cells and everything. And you can see whether the effect of the plasma that you expect, based on your hypothesis, in this case causing vascular leakage, is actually observed in vitro. So you have the real world observations, the hypotheses, and right now it is a nightmare to get this done. So nobody should tell me, oh, it's easy to get to the data. No, but they can also not be open. So this is a data model we developed in 5 phases, healthy patients or sick but not yet having severe lung problems. And in the end, you can see here that people basically die from lungs that are completely dysfunctional, and they get actually multiple organ failure. But the cytokine storm and a number of other things that we have here with a lot of genes, 47 genes, seem to be involved in driving hypercoagulation, vascular leakage, which is of course a deadly combination when it comes into a particular organ. Could be your heart, could be your brain, could be your lung. And of course you get different manifestations and you die sometimes from multiple organ failure, but it is always in essence the same system underlying this in broad strokes. So the virus interacts with a number of genes, proteins in the human proteome that can cause cytokine storm, totally different from the hypothesis that it works via ACE2 and RAS. But in both cases, most people get better even before they go to the hospital. They could still take aspirin or some things to help them a little bit. Then some people get into a full-blown cytokine storm, and some of those develop leakage and thrombosis, and they get severely ill, and they go into the intensive care. And then, of course, maybe here it makes no sense to put people on a ventilator anymore because the lungs are completely collapsed with lymph that has been pushed out of the microvessels in the lungs. So this model can be now used to test all the drugs that we just took here from Wikipedia or Wikidata, and we threw them theoretically in silico in this Petri dish and saw, for example, that hydroxychloroquine has hardly any connections in the model, of course, to heart failure. But some other drugs that you see here have very strong connections and have a much higher chance to mitigate some of the stuff that is going on here causing disease than others. For example, aspirin has a lot of effects on many of the genes that are involved, including IL-6, and is potentially possible that it can prevent, at not a very strong level, but this switch to a cytokine storm or an aberrant immune system, because it also affects IL-6, for example. And in some cases, you are much more severe. You need monoclonals that very specifically inhibit IL-6, for example, like tocilizumab from Roche. But if you are already in a full-blown cytokine storm, or the virus causes thrombosis and vascular leakage without a cytokine storm, it doesn't really make any sense to give these patients, an IL-6 inhibitor. So we have to be aware that a COVID patient is not a COVID patient. You have to really look at the stage in which they are, and only slowly, by measuring all these cytokines in large number of patients, these patterns come clear. And dexamethasone and heparin have already saved a lot of lives. Drugs that we use all the time, if you give them at the right moment to the right patients. So here you see the dexamethasone that just came out inhibits prostaglandin E2, which is one of the major intermediaries leading to vascular leakage. So we can now finally see in a very complicated analysis that I cannot explain to you right here, how this might work under the hood. But if, and that's the final part of my presentation, if we do not invest serious funds in ensuring that data are reusable, this is impossible. So this distributed analytics system, where the data stay where they are, in China, in the United States, in Iran, in Italy, with all the political hassle that is going around COVID at the moment, none of these countries is going to send their data across the pond or even to WHO. But if we spend about 5% of every research project on proper data stewardship, and we make the data fair and visitable under well-defined conditions, then we could have made the pictures that I just showed you months earlier. And I don't have to explain anyone in this audience how many lives that could have potentially saved. So yes, open data saves lives, but I would rather specify that and say that fair data save lives. Thank you.
Welcome back. Thanks very much, Baron. That was a great talk. Unfortunately, Baron can't join us for the Q&A at this time, but if you have any questions, please put them in the chat. We'll forward them on, and we'll try and pick them up in the wrap-up session on Friday. Next up is Jenny Tennyson, Vice President of ODI HQ, with Friends. So this is almost a TV program, mini TV program by ODI HQ and Jenny Tennyson.
Thanks very much for having me here at Northernlands too. My name's Jenny Tennyson. I'm Vice President and Chief Strategy Advisor at the Open Data Institute. And this session, we're going to focus on talk about the creation of standards and use of standards in an emergency situation like COVID-19. I come from a background of using standards. That was how I got into IT, into development, into software engineering, and into open data. So my involvement with W3C, with the World Wide Web Consortium, really was what put me on the path that I'm on at the moment. I love standards. Standards, I think, make the world go around. They make our lives so much simpler. But I've been questioning the degree to which standards are useful when you have to move fast. And that's the real question that I want to dig into today. So standards for data we define as documented, reusable agreements that make it easier to publish, access, and use data. So the crucial thing there is that standards are supposed to be there to make it easier to work with data. If you have a standard, then you don't have to think as hard as you would otherwise about how to exactly publish or use it. You don't have to go through the same thought processes that everybody else has gone through in working out what to do. And standards aren't just about, data formats and exactly what schema to use in a CSV file, for example. Standards can be things around identifiers. They can be what units or measures you use or what questions you ask. Standardizing things helps people to understand what you're talking about. We did a project a while ago on developing standards that really highlighted how many different ways standards can be useful. And if you go to standards.theodi.org, you'll see a set of guidance about that. Now, the thing about standards is that they do take time to build. And crucially, that's because it involves working with and negotiating with lots who might have their own ideas about what should be in a standard or how a standard might be used. And it's that time-consuming nature of standards that makes them so difficult in an emergency situation. In April, we started a project on open data and COVID-19. And throughout this project, looking at the way in which data has been used through this emergency, we've noticed a real lack of standardization. basically everyone is doing their own thing. And that's surprising because of the cost of that negotiation, the cost of actually developing a standard that slows things down. But we're wondering, is there a point when you should start to standardize data? Is it a case that there's more haste if you don't, but less speed overall? And so to dig into these questions a bit more, we're sharing today 2 interviews with people who've had to actually deal with health data during this crisis. First of all, I'm going to hand over to Olivier, who's our head of R&D at ODI, to interview developers behind Track Together, which is a symptom tracking app. And then following that, we'll have an interview with some of the NHS team about how they've been using data and the kinds of standards that have come through that. So first of all, over to Olivier.
Thank you, Jenny. So for this interview, I'm joined by Rashid Wahib and Guy Nakamura of the Track Together team. We've been working with the team at Track Together for a few months now. They contacted us when we started our project around the month of April, and we had a call for anyone needing help with data around COVID-19, and they were actually one of the first organizations joining us. Guy, you've been working on a symptom tracker app for a few months now, sharing some of this data collected through your app with academics. Was that always the goal?
Yeah, I'd say so. Rashid and I started Track Together about 3 months ago. So when COVID-19 was really first coming to public attention in the UK, we actually started with every intention of it being a quick weekend project. And this was ultimately because lockdown measures weren't in place, there was inadequate testing, and neither the government nor the public really had any idea what this virus meant and what we were facing. So in light of that lack of information, we built the first web version of Track Together, with the ultimate ambition of offering people better visibility of the disease in their communities, and with every intent to share this data with both academic institutions and public health authorities around the world. So,
thank you. Rash, so the collaboration that when we started our collaboration, it was around opening data, or at least it became about opening data. You've been now publishing anonymized open data from the data you've been collecting through the app. Now it's gone through several iterations. I was curious to hear from you, what would you say were the easiest and hardest facets of that work?
Yeah, so the hardest part was definitely setting up the entire pipeline from the raw data set to the open data set, and understanding some of the pitfalls in it, and understanding what can be shared and what can't be shared. So obviously the ODI helped us a lot there, understanding that at country level we can share data, but maybe not at postcode level, given that within a postcode and an age, having those 2 together, you could potentially identify a single person. That was one of the issues. Also, we started opening up the data quite late, so we hadn't set up the pipeline. We didn't value open data as much as we should have from the start, and had we known, we would have introduced this pipeline with our development pipeline. So one of the things that was quite easy in that going forward was using GitHub, and understanding, with the ODI's help, understanding that's the platform to go forward with. As an application engineer, very familiar with GitHub. And there was music to my ears being able to use it.
Thank you, Rashid. So the next step in the collaboration that we've had, and it was no longer just about you publishing data, but really starting a coordination with a number of other teams. There are quite a few symptom trackers, not just in the UK, but internationally. And your ambition seems to be to harmonize the work done with COVID-19 symptom tracking data. Guy, I'd like to hear from you. Where did this impetus to do so, to do that harmonization, come from? And why did you decide to explore standardization and harmonization rather than, if I can give a provocation, rather than merging all the apps into fewer apps or just one?
Yeah, of course. I think as we gained traction and the severity of the virus really started to come to light, we realized just how important the work we'd done was. we'd started to come across more and more similar initiatives, whether citizen, government, or company-led. And each and every one of them had very similar ambition to share this data with health authorities, academics, and other various parties. And these trackers were ultimately popping up everywhere, from Brazil to Vietnam to the UK and the US. And ultimately, while in the UK, collaboration was started to take place through the government-led Project Oasis, which we are a part of, kind of led by the J-Hub and the NHSX, sorry. We always had a much broader goal and a more transparent, or should I say open goal, than that of Oasis, because that data is ultimately going to the government. And of course, we hope they put it to good use. But we thought there was a broader need for this, as we saw that the virus wasn't just affecting the UK or the US. It's a global pandemic. And I guess why standardization rather than there are a few reasons for this. One really was the speed at which we were all moving. I mean, of course, there's kind of initially a two-man project, but we are a much broader kind of volunteer team now. We were able to deliver really quickly, whereas governments obviously take time with due diligence and bureaucracy. So lots of manpower have been invested by various projects, and I think it would have been too tough an ask to really get them to merge into one. Secondly, I think there was a lot of value in the varied approaches taken by these trackers. For example, we place a lot of emphasis on our social influencer campaign to grow our audience. And we naturally meant that would be hitting a different demographic to, say, COVID symptom study. And then thirdly, I guess, merging all of this into one app would raise a lot of questions about who owns the data, where is the data sitting, and how it's ultimately going to be used. So I think there's a huge benefit in having all these various actors in the space.
A quick follow-up question to you, Guy. If standards are important, why do you think that one hasn't quite emerged yet, or has one emerged yet that you're seeing that needs to get people around it?
No, nothing really, which is why we've ultimately come to the ODI for help on this. I think it's been very difficult because there have been so many unknowns in this. We've never faced this sort of situation previously, and as I said, there's so many different actors in the space. So we are just ultimately a volunteer organization, but then you've got governments and different third-party companies working on this. And I think ultimately we haven't had the time for that coordination. And as you've rightly pointed out, this does take time, and we've only been kind of months into the pandemic so far. So I'd say that is why there hasn't been one yet, but there is very much a huge need for it.
Great. So I'm going to follow up with a question to you, Rush, again in the same space about stewardship and organization, but more about the long term, because there is a case to be made perhaps about the fact that symptom tracking was only useful at the very beginning to try and understand the pandemic as it was unfolding. What would you say to someone thinking that symptom tracking is yesterday's news? And who do you think this data that you've been collecting is useful for in the long run?
So, what we found with the Track Together project was how the use of the data evolved over time and with different parties coming to play. With a single set of data, the use managed to evolve. Initially, it was a public application that people be able to see data within their area. So a lot of mapping happening. That later evolved when we had the J-Hub, NHS involved, and some universities. We were able to provide specific data for their research. And going forward, I think the applications are fairly endless. I think there are applications in business. I think we've seen emerging economies, particularly in education, which is one of my job. So in education, we've seen people move from schools to homes, and I think in the use of business intelligence, you can see how symptoms over time, how they changed, and how that affected children in schools, and how that shifted an economy. That's just one usage, but I think we'll see this data being used a lot for business intelligence, a lot merged with public health initiatives, a lot understanding demographics. So I think those are just some examples. I think that's just with this small data set. I think going forward, symptom tracking with our standards that we get into place, hopefully, I think we get a framework together to fight any future pandemic, any future disease, any future effects of public health. And I think that's how it's evolved. So something so small, or something small, has evolved from pet project to researchers to potential commercial applications. So that's how I see the data is useful in the long term.
Well, that's all we have time for, but this is a great way to finish on all the possible impact of this data if it's shared, and if it's shared more consistently. So I'm looking forward to working with you on that. Rashid, Guy from Track Together, many thanks for your time. Jenny, back to you.
Thanks, Olivier. Now, earlier in the week, I spoke to Indra Joshi, who's Director of AI at NHSX, and Ming Tang, National Director of Data and Analytics at NHS England and NHS Improvement, about their experience building the COVID-19 data platform within the NHS, and the wider work also within the NHS needing to wrangle data. I wanted to explore with them what they'd learnt in that process, and particularly about whether and how standards are useful in an emergency. So Indra, set the scene for us. What have you been building and why?
Hi Jenny, thanks for that question. So essentially, when the pandemic hit the UK, those of you who will know about how we approach data in the UK, know we have multiple different data sets that are held in multiple different locations. And so one of the key things we wanted to do, and one of the fundamental key areas to actually ensure everybody understood the numbers and that the same number was interpreted in the same way. So what we did was we spoke to quite a number of people, both across government and across the NHS, and we said, look, can we actually bring some of these slightly disparate data sets together in a way that will then help some of the strategic decision makers, both in government and in regional teams, understand essentially what the numbers were. So what we did was create a database, for want of a better word, for different data sets across England primarily, so that operational teams could understand the core fundamentals, such as how many beds we had, how much oxygen, ventilators. So that's kind of in a summary what we've done.
And Ming, we often hear that NHS data is a bit of a mess. To what extent was standardization or lack of standardization a problem in the data that you were bringing together like this?
Thanks, Jenny. It was actually a big consideration. Some of the things that Indra just mentioned around counting beds and ventilators and all those things are strict counts, but we don't have electronic means to gather that information automatically. So we had to create data collections. Therefore, any data collection that you create, you have to make sure you've got a consistent way of counting things so that the people that are replying are actually counting them correctly. So we had to think about creating definitions, how we then use that information to make sure that we could compare apples with apples. Things that weren't physical equipment, they weren't counts, we also had to think about how do we de-identify the information, collect patient information, so data sets such as ICNARC. It's really important that we have that information because that gave us a wealth of experience of how the COVID treatment was going and what was happening to patients. So we had to be very careful, even with the COPI regulations, that we de-identified that, created a COVID-specific pseudonym so that we could link data sets together, but without, any of the privacy concerns, really. So we had to have quite a wide-ranging discussion with the IG colleagues to make sure we standardised how we de-identified data, how we then processed it, and then allowed linkages. All of that's really important. And yes, you're quite right, NHS data is usually quite messy. What we have learned is that the core reference data sets that we hold, like organisation codes, places like care homes, which were, you would think would be quite easy to have a registry. We didn't have one of those at the beginning of the pandemic. We now do. So we have had to create a lot of those registries, which has been fantastic. And then making sure that the consistency, not in just the definition of counts, but definition of, when testing results are happening, within 24 hours, within 48 hours, all those kind of clear definitions so that we can enable consistent analysis was really important as well. So that's kind of the things we were looking at. And I think we've learned a lot. And I'm really proud of the pace at which we actually delivered some of the data and analysis as part of this experience, I guess.
And Indra, obviously the pandemic is an international phenomenon, but we're not seeing very much standardization about the way in which data about the pandemic is being published by different countries. Having been on the inside, what's your kind of insights? Why do you think that is?
I mean, I think this could go back to the kind of the wider issues with data collection. I mean, quite often, even inputting at source, I'm not going to go through the kind of usual problems that we have, but, EHRs aren't designed for us to actually input data in a way that is easy to do and standardized. And also, as Ming mentioned, there's quite a lot of different interpretations. So, for example, here in the UK, we call our ventilated beds O+, or V beds. Now, that's because we're here in England and we've kind of made that category, but it might not be the same in other countries. And obviously there's a different language. So I think there's a huge amount of work still to do around data standardization. And we, for one, as Ming mentioned, we found it quite challenging as well, especially when bringing people from different backgrounds together. For example, data scientists working alongside clinicians, actually to understand those disparate data sets. There's quite a bit of effort going on internationally, such as communities like the Odyssey Network, which is looking at they call them common data models. So countries across the world can start categorizing in common data models. We as well are doing quite a lot of work around using open standards. So again, that we're kind of encouraging people to code in a much more unified language. And then I guess we all have a role to kind of drive this forward across multiple channels, both the clinical community, the research community, and as well, I would say the tech community has a big role to play.
Ming, one benefit of standards is that people get familiar with them and then they can use data that's using those standards really easily. But when we have a world where we're bringing together data from that isn't in those standards, and people can't make those same assumptions, what do you think the people who are producing this data need to do in order to mitigate the potential for misunderstanding?
I think it's really important that any data owner actually has very good metadata associated with that, and that those definitions and standards are actually published alongside the data so that it can be interpreted in a particular way. One of the things that we found during this pandemic was really using the data, particularly around modelling, and making sure that we had clear sets of assumptions that we were all using, and making sure we were transparent about those assumptions, both between the national teams, the regional teams and the local teams, because there is an opportunity to interpret this quite differently, even in how we count the number of O+ beds and what an O+ bed is. In different sites, they'll be classified as different things. So making that case, it's really important for the metadata and the definitions. And then for modelling, what we found was it created an even bigger need for collaboration. And to do that well, we have to have really good documentation, not just the codification of what we've modelled, but actually documentation around the clear assumptions, the objective of the model, the hierarchy of the models, their interdependencies, and really making sure that if we are using a particular data set, how that data set is refreshed, replaced during the period of which that you're looking at. All of this stuff is really important, because otherwise you can't actually compare and make best use of the analysis that comes out of it, because we were using a lot of our modelling to then drive our operational decision making. I think that's really important. We were able to make a case for lots of local decisions through better use of data, that we were all tied together in the platform that we used.
And finally, Indra, are there any other places where you found standards being used within the health system to help respond to COVID-19?
Yeah, I mean, quite often when we talk about standards, the first thing that springs to mind are things like interoperability standard, data standards, and the kind of technical side. One thing we're very conscious about is there are a wealth of other standards out there, such as the regulations, and we here in the UK have something called accessibility standards and clinical safety standards, which I think are imperative when you're actually building either a device or a mobile app or a remote monitoring tool for whoever it might be. And the reason these things are really important to consider is, especially in speed and in haste, sometimes these things either get overlooked or there's suddenly a consideration right at the end of that development cycle, which fundamentally, when you're looking after people, and I speak as a clinician hat on now, is, human care. Don't do harm, do good. These are things that are fundamental that we as clinicians are trained to believe in. And sometimes when you kind of mix technology and clinical things, sometimes those thoughts are afterthoughts. And so one of the things we've done is we've published what we call a digital health technology standard, which encompasses quite a lot of these things. So, going from clinical safety to cybersecurity, understanding privacy. So we've got the GDPR, for example, and also to consider if your product that you're building is a medical device, because as some people may know, the medical device regulations are changing here in Europe. And so we do have to be quite mindful about these things. So I always think it's important to build these in in versus thinking about them at the end. And so this is why we've published some standards predominantly around the wider aspects versus just the more technical side. So people can consider these right from the start of that design process.
Thank you so much, Indra and Ming, for all of your insights. So having done those interviews and looked at the way that standards are being used across different parts of the system, it really strikes me that the process of standards that's useful is the one that involves engaging with the range of needs from different stakeholders, and the process of exposing and resolving different kinds of assumptions and differences that you have in order to get to data that is useful and comparable, so that you can bring it together, so that you can aggregate data from different sources, so that you can compare, for example, how different countries are doing. What we've seen is that right at the moment, aggregators are the standardizers. So, for example, with the Track Together app and symptom tracking, they talked about Project Oasis, a project that's being run by the NHS to bring together data from a number of different symptom trackers and to create basically a common way of viewing data from that range of different applications. Or if you look at the kind of data that is being published from countries about cases and deaths and testing and so forth, currently the way that most people are using that data is through the European Centre for Disease Prevention and Control activity that is bringing together 500 different data sets from different kinds in a process that they don't actually give very much information about, in order to create those comparison graphs and so on. So those aggregators, the people that are doing all the processing of pulling together data, aggregating it together, are the people who are in effect creating standard ways of seeing data from, say, symptom trackers or about cases and deaths. And they're doing the work of the standards body, if you like. And really what we should be demanding from those aggregators is that they document the models that they're coming out with, which naturally will have some commonalities because they're pulling together data from lots of different sources, and open the code that they're using to map into those standards. If we do that, then at least we have a starting point for some standards that perhaps we could evolve a little bit more. Second thing that strikes me is that data publishers have been operating in quite a heads down way in terms of thinking about who is going to reuse data, but also what other people are doing, what other publishers might be doing. And some of that is justified. Indra talked about how different countries have very different ways of thinking about and structuring their information. But it would be a fairly low effort form of standardization if publishers just looked at what other publishers are doing and tried to copy it using the same headers in their CSV files, using the same kind of structures, for example, would give a kind of gradual convergence towards something that was a bit more coherent and that people could reuse without having to understand the depths and complexity of each individual publication. Again, you know, documenting and publishing the models that publishers are using and the assumptions behind the figures that they're providing would give us a kind of leg up to something that was a bit more standard and a bit more coherent. But then the third thing that really strikes me is, what are we missing by not engaging in a proper standards process? We've seen a number of areas where publishers aren't providing data because they're not really thinking about who might reuse it outside their particular bubble, their particular people who are shouting loudest in their ears. Right at the moment, we've got news about the way in which data published about testing in the UK hasn't revealed the full extent of cases in places like Leicester. And that's really a deficiency in the way in which data is being published, because people aren't listening to the needs of organisations outside of their particular bubble. The same was true around the publication or lack of publication around ethnicity data around COVID-19 cases and deaths. Having more people involved in the process and engaging more widely with potential reusers is one of the things you do when you're doing standards, but you don't have to be doing a standard in order to do that engagement. I do think that some of these gaps would have been highlighted and caught much earlier on if there'd have been a more inclusive process and a more thoughtful process about the way in which data is being gathered and published. So my kind of conclusion around standards development, as I say, I think that the process of standards development is the thing that gives its power, the way that it involves different stakeholders. And if you can't do that, if you can't do the full standards process kind of rapidly in an emergency situation, you can at least talk to other people who might have an idea about how data could be used and reused. You can at least look at the way in which other people are publishing data, and aggregators and those who are going through the exercise of pulling together different kinds of sources can at least document what they've done, and perhaps provide some of that code as open source so that we can all benefit from it. But I'd love to hear from you. What do you think should have been done, and what could we do now in order to get better standardized data to help us deal with this emergency?
Thanks very much. What an amazing talk we had there. Well, I'm joined by Jenny Tennyson and Olivia Through from ODI HQ. They're here to take some questions that have come through. And the first one up is, I guess this one's for Olivier. So the open symptom tracking data, where can we access this?
So there's two facets to this answer. The first one is most of the raw symptom tracking data should probably not be made open. It's quite sensitive, and therefore it needs to be made it needs to be anonymized before it can be made open. Now, the reality is that because it's distributed and you've got a lot of apps and a lot of teams doing symptom tracking, there's a variety of practices around how and whether they publish data. You've got, Track Together, which we interviewed, they are an exemplar in my mind, in that they have published anonymized data with a good documentation. Others are doing a little bit of it. Zoe, for instance, are publishing dashboards, which is not as good as publishing raw anonymized data. And some others are not publishing anything at all. And I think that'll be part of what we're doing, is to push them towards at least harmonizing that publication of some open data, but anonymized.
Absolutely, and to get the benefit of the tracking data, some of that must be shared, I guess, because how do we amplify and really capture the benefit of that? Because otherwise, it's sticking things in the bottom drawer, I guess. With specific access.
And it would be quite hard then to understand what kind of data they have without that.
Yeah, and we need to share something at least, don't we? So that
Olivier, sorry, Paul. Have we got a link to the Track Together open data that we can share in the chat, maybe? Yeah, that's
yeah.
nice.
I'll share that. Yeah,
fantastic. And then the second question we've got is around standards, and should we set up a central standardizations body to make all this happen? I've got my points of view on that, but Jenny, I guess if you could share yours.
Well, I mean, of course, there are already a whole bunch of central standardization bodies or standardization bodies of various kinds, whether you're looking at IETF for internet standards, Web Consortium for web standards. There are specialized standards bodies for particular types of data, say in the health sector. It's not that there's a lack of standards bodies. For me, then what there's a lack of is standards practice from individual organizations who are needing to decide how to publish data or decide how to collect data. And I'd quite like to see that process of creation of standards a bit more democratized, really, so that if an organization realizes that it needs to collect data from a whole bunch of other organizations, it can go through a standardization process itself, suited to its particular community, that creates that, rather than needing to go through a central standards organization. But it takes practice to do those things, and hence why things like the standards guidebook, the standards.theodi.org is, we think, a helpful thing for those organizations. What's your view, Paul? You said you had opinions.
So I think my view is we need to amplify what works, and the more data is used, the more useful it becomes. And at ODLEs, we talk about three things: story blogs to tell people what we're doing, and technical blogs to tell people how we're doing it, and then a repo with data encoding it. And there's a secret thing to this, is that there is a thing called the web, which you can share and search for information. And if data is being used, and we find that this is a great data asset, and it's a great data set, it works, it's in a pretty good format, let's use it more and tell people we're using it. And then that way, the standards will emerge. Yeah. And most people are using data, know pretty well what's working and what doesn't. Your point around democratization is so important, where I think there's maybe I'm a little bit unfair, but when people set up an institution, there's already an institutional thinking to land grab, and we own this and it's ours and it will be forevermore, and forevermore it will be. And then that needs to pay for our chief exec and our team to do that. And that really needs challenging, is that if the data is not being used, then you're probably not doing your job, and we need to call that out.
Yeah. So I really agree with you, and it was in the talk around, organizations that are publishing data should look on the web for best practices for what or other organizations are doing and copy those rather than coming up with their own thing. But it does also mean, as you point out, organizations that are publishing data or doing stuff with data also publishing about what they are doing so that others can copy from and borrow it. And that more open mindset is how we iterate towards something that looks more interoperable, that means that you don't have to reinvent your parsing stuff, your parsing code all of the time, but without having a big burden over the top, right?
Yeah. So maybe, and when we talked with Ben earlier on and afterwards, we've had long conversations over the last 3-4 months, is how do we fund teams to do this rather than projects to deliver upon? And once the project's finished, no one looks after it anymore. So that maintenance piece, funding teams, not projects, is something that I think all of the people who we've got common cause around this. So we need to think about that. And I guess that's why when Mark was talking about what he does next with Open Data Saves Lives, which by the way, ODI Leads doesn't own, it's just a hashtag we put together. Anyone can join in, is really important, how we try to fund and develop the people who are going to maintain and do stuff with data. And maybe lose a little bit of the requirement to own or have a chief exec or a shiny front door. It's just projects that need to happen delivered by teams. So I guess that covers our point really. I was going to say next, how do we amplify all this great stuff in energy that we've seen all over the place? So we're doing it ODI Leads through Open Data Saves Lives with our partners. We're really happy that ODI HQ are going to be funding part of the next phase of Open Data Saves Lives through their open access initiatives, which is amazing. Olivier and then Jenny, what do you think we should do next to capture the energy?
I think the way I would push it, and I'll try to answer one question there's in the chat just now, is allow for things to grow organically and then highlight good things that you see out there. And it's echoing what we just said, but it especially in the current context, big initiatives are going to be too slow and might not yield good progress. When you are facing a problem, looking at who is doing it, and then instead the energy that you might put into starting it from scratch and reinventing the wheel, actually use that to highlight something good that you found out there, to work with the people that are doing that. So again, the interview that we had with Track Together, that's been quite organic. They have been organizing with other symptom trackers in the UK, in the US, and elsewhere, and that is organic, and that is grassroots. We've got good ways of having grassroots work, starting from one person and another person finding it and saying, "This is good. I'm going to help you," and this is how we get that snowball rolling, I think.
Fantastic. Jenny?
So I think that one of the things that we need to recognize here is that the work of using data, of comparing data that's come from different places, of documenting how to what different fields mean, and there's a whole bunch of work that goes around publishing data that, in particular, in a time of crisis, people don't have the capability of doing because they're too busy kind of just concentrating on getting the very narrow things done. And I think that there's about recognizing that actually contributing in those ways to activities that others are doing is itself a useful contribution. So, the kind of convening that you're doing, Paul, the kind of research that we're doing at ODI, comparing different sources and what's coming out of those different sources. These are all additional activities that we then need to make sure get out there much more broadly across the community. I think the thing that is really difficult is getting that kind of awareness back into organizations who are operating very, very heads down, and that's a challenge that just working in the open doesn't actually fix, because you need quite targeted really badgering of the people who are doing those pieces of work, because they're needing to concentrate on their immediate priorities. And so
yeah, that's the other kind of area where I think we need to have a bit more attention.
Yeah. So thanks very much. I'd just like to say thank you for joining us. And I guess that badgering and helping, and I think we've all just got to help each other to keep on we might need to pass the baton on to each other to keep the energy going and join in with that. So thanks so much for joining us today. It's been great. And next up, we've got David Egan. He's talking about open data saves lives if you have the tools to mine the data. So hopefully we're going to get some answers from our North Sea neighbours in the Netherlands. Thanks so much, guys.
Thanks, Paul.
Cheers.
Good afternoon. My name is David Egan. I'm the CEO of Core Life Analytics. Core Life Analytics is a company that helps biologists to analyze their own complex data. Now, I'd like to thank the organizers for inviting me to speak here, ODI Leeds and the MC of the Netherlands. But the first thing I have to start with actually is an abject apology, because I realized that in the 3.5 years or so that Core Life Analytics has been active, I've never actually had a business trip to the north of England. They've all been either to the obvious Oxford, Cambridge, London triangle in the south, or Scotland in the north. So yeah, I realize there is some very good work going on in the north, and I promise this is something that will be addressed when we're allowed to travel again. My interest in open data stems from the fact that during my postdoc in California back in the late 90s, I got interested in a relatively data-intensive area of biology. And this was in the use of automation for biology. And so what we were doing in the lab I was working in California is we were using robotic systems for setting up experiments in plates like this. And so this is a 384 well plate, and what you can see is that you can set up an individual experiment in each of these plates. And so this is technology that is used heavily used in industry and also in academia. And this use of this technology turned into a career in what's known as high throughput screening, where I actually ended up delivering these automation services to groups in industry and in academic centers. My last position before founding Core Life Analytics was as the manager of a screening facility called the Cell Screening Core at the University Medical Center in Utrecht. There we had for carrying out high throughput screening assays and microplates, but what we also had was an automated microscope. Essentially, this is just a microscope in a box that allows you to take images of cells in those 96 and 384 well plates that I described. Now, the automated microscopy gives you access to a technology called high content screening. And this just describes how it works. Basically, you can take images of fluorescently labeled cells using your automated microscope. And then with automated image analysis software that generally comes packaged with the instrument or open source software, you can extract numeric descriptors of the cells that you've been taking images of. So for example, if we look at this nucleus, we could extract numbers that describe the area, the shape, the perimeter, the intensity of the nucleus. Similarly, with the cell, we can identify shape, we can identify intensity of various labels, fibers, etc., spots. And of course, all of these numbers create a profile that's essentially describing the actual morphology, what this cell looks like. The power of this technology is that that profile is actually related to the mechanism of action of some chemical or genetic reagent that you might be testing. And so how it's used is that large libraries or smaller numbers of chemicals or genetic reagents can be tested in these plates, and then you can generate profiles that are related to the activity of the chemicals. Now, one problem we had at the Cell Screening Core is that while we had all the technology required to generate the images and extract the numeric features from the images, we didn't have any tools in order to help our clients analyze the data. And so essentially they couldn't make full use of this technology and do what we call multi-parametric analysis. In order to solve this problem, I hired a graduate student, Veena Domta, who subsequently became my co-founder at Core Life Analytics. And what we did was we built a web-based tool called HC Strataminer. And the idea of this tool was that it would allow biologists to upload their data from these high-content screening experiments, and then it would walk them through a data analytics workflow. So it would allow them to isolate the metadata, carry out variable selection, essentially throw out the garbage, then do QC on the data, things that are specific to these type of experiments in microwell plates, plate normalization, transforming the data, scaling the data, and then on to what's known as data reduction or dimensionality reduction. This would reduce the very large numbers of features to a smaller number of relevant scores. We could then use these to identify the outliers based on these profiles of numbers. And so essentially these were the ones that looked different from something else or looked similar to something else. Then we can cluster these to separate out the different types of profiles. And then if we found something interesting, we could build machine learning models and then apply these to the whole data set. So essentially this meant that what we were doing was we were allowing biologists to analyze their own data by turning data science into data technology. Initially, we were able to test and validate HC Strataminer using data generated at the cell screening core, but we quickly found that we needed larger and more complex data sets in order to really push the envelope and to show the value of the platform. Fortunately, in the high content field and the image-based screening field, there are a number of good open data repositories available. So the first one is the IDR, the image data repository that was built by Jason Svedlow and his group in Dundee, and the other is the Broad Bioimage Benchmark Collection that was developed at the Broad Institute in Cambridge, Massachusetts. So let's have a quick look at those. The Broad Benchmark Collection is quite straightforward. Basically, the idea is that it is a collection of high-quality image sets that can be used for benchmarking, and most of them have some sort of ground truth built into them. And so here you can see the collection of data sets, and what you can do is if you open a particular data set, you can get introduction to the experiment that was done, a reference, and then the images and whatever metadata is available. But it's simply a repository. You can't view the data or browse the data. You simply get some information about it, and then you can download the images and download the metadata that's available. The IDR, on the other hand, is far more elaborate. This is not only is it a repository for many screens, it gives a lot more functionality as regards browsing the data. So here, for example, you can search for a particular data set, and then it opens up here, and then you can see on the left all of the individual plates. And when you click on one of these, the actual plate pops up, and you can see a kind of a plate-based map of all the images. If you want to look at one of the images more closely, then you click on it, and then up pops this elaborate browser. This is really cool. You can turn on and off the various channels here. You can adjust the scaling. You can actually copy and paste the scaling so that you compare multiple images using the same scaling. It's all quite elaborate. And when you go back to the actual screen, you can get information about the metadata that's related to the well, the compound structure, for example, the compound name. Also, at a higher level of the screen, you can download. There are files of metadata here that you can download. It is also possible to download images from the repository, but it's not as simple as the Broad repository. You need to interact with an API, but it is doable, and you can get some help online to figure out how to do that. One very interesting screen that was present in both the Broad collection and the IDR was based on a paper that was published by Neil Carraher from the University of Edinburgh back in 2010. This was interesting to us because it was a small molecule high content screen where Neil and his group tested 102 drugs in 8 different concentrations against a number of different cell lines. And the images to the data from one of these cell lines, MCF7, was uploaded into the repositories. And so these are the various compounds that were tested, and what was of interest to us was that they were from a wide variety of different mechanisms of action, and these mechanisms of action were well annotated in the metadata, along with the concentration and the various structures of the chemicals themselves. So what we did was we collaborated with Johnny Sexton at the University of Michigan in the US, and Johnny's group downloaded the images and ran them through Cell Profiler. So Cell Profiler is, as I described earlier, an open source image analysis software, which is extremely powerful. And so then we were able to take the numeric data that Johnny extracted, and this was 479 individual numbers, and this was done at cell level, meaning we had 479 features for every cell in the data set. And so this rich, large data set we were able to run through Strataminer, and again, as I described earlier on, we were able to upload the data, identify the metadata, and then carry on to the process of normalization, transformation, and scaling until dimensionality reduction. And then at dimensionality reduction, we were able to reduce these hundreds of features down to 9 robust individual scores called principal components. And Strataminer helps the user to decide how many different scores they should calculate in the principal component analysis. Let's jump into the Strataminer platform. I can show you a little bit about how this works and then what we did after this dimensionality reduction step, because this starts to get very interesting from this point. So here we are in the Strataminer web-based platform, and here on the left what you can see is the workflow that I described earlier, and now we're at this step here, the dimensionality reduction. And so what I've done here already is I've processed the data, and we've taken 336 features, and then we've reduced them down to 9 different what we call principal components. And the platform makes it very easy to investigate these different components, and you can see here what sort of features are loading on the different components. And then these individual scores, you can see how different types of chemicals actually trigger different scores and are related to different principal components. And so this is essentially the biology coming out in the data reduction. Now, as you can see here, this is kind of an indication of how the larger number of hundreds of features are reduced to 9 individual scores. And then we can take these individual scores and then we can carry on and use them to actually do hit picking in the next step. So what we do is we hit save and continue. And then what we can do is, just to demonstrate how we do this hit picking, we can generate here a 3-dimensional plot using just 3 of these different of these 9 principal components. So let's have a look at this. Now, here we've all these different classes of wells. These are all of the wells in the data that we've processed here. And let's turn off these ones, the samples, and let's just look at some pretty obvious controls here. Okay. Now, all of these are color-coded. And so these negative controls here, the ones that we know nothing should happen, are labeled in red here. And then we have various different types of controls labeled in different colors. The green ones are positive controls, where we know there's going to be a phenotype. Now, if you look at these positive controls, you can see that they're far away from the negative controls, okay, in 3-dimensional space. Here we're just plotting 3 of the components. And that's actually how we define our essentially phenotypic hits. These are far away because they look different from the cells in these wells. And what we can actually do is we can actually measure the distance from the negative controls to each of these. And that's indicative of how different they look. Okay. And then that's what we do. We actually calculate a geometric, what's called a Euclidean distance for each well. And then that can determine whether it's actually a significant outlier. So let's do that. We'll select all of our components for this, what we call hit picking step. And then we're just going to calculate the distance for every well from the negative controls. And then what we get is a list of hits. Then all of our distances are visualized. And here we can see our negative controls, and then our positive controls. Then these are all the samples that we're testing, and then we can see that there are a number of hits here, things that are significantly different from the negative controls. And then these are dumped into a list, and then we can sort this list, we can filter it, and so on. Now that we've isolated these hits, what we can actually do is we can go back to the original 9 principal component scores, those 9 reduced scores that we generated, and then we can do clustering based on those scores. And here you can see the clustering. And now this is the beauty of the high content analysis, because now what you can see is that the chemicals here in the hits are actually clustering based on their mechanism of action. So what we can see here are cytochalasin, latrunculin, and cytochalasin, latrunculin. These are all actin inhibitors. Farther down here, what we can see is Taxol, epothalone B. These are all microtubule compounds. And then over here, what we can see is compounds that are DNA damaging agents. And so this is the real high content paradigm, where we can take images, extract numbers, and then isolate chemicals that are giving us an effect, and then we can separate them according to mechanism of action, all based on a cell-based assay. So this is just another look at that clustering, and you can see here's our DNA replication and damage agents that are clustering here, and then down here are our actin inhibitors, and then our microtubule modifiers. And another thing we can do with this distance score that we used is that we can actually plot it against the concentration of the chemical that's being involved. And what happens is that then, as you get an increase in concentration, if it's a bioactive, you get this nice sigmoidal curve. This makes it very easy in order to identify chemicals that are giving a biological effect. So if we look at that a little bit more closely here with one chemical called docetaxel, this is a microtubule inhibitor, what you can see is that as that distance score increases, we see the phenotype coming out. Here is one with a low distance. These are very similar to the negatives, intermediate distance, and now here a high distance. And you can see this is a very strong phenotype. If we look at latrunculin, which is a chemical, a drug with a different type of mechanism of action, it affects actin, then what you can see is also low, that looks very similar to negatives. Medium, you see the phenotype starting to come out. And then with a high distance score, you can see there's a very strong phenotype. But it's very obvious that this is a very different phenotype from docetaxel. And so this is why they cluster separately on that hierarchical clustering diagram. Then what we can do is, because we have data at cell resolution, we can actually build AI models. And this is another way of doing the analysis within StrataMiner. We can isolate interesting wells that we have found during our clustering analysis, and we can label those and then use them to build AI models. Here we've built a random forest machine learning model based on these different reagents. And then what we can do is we can ask the question, okay, what wells look very similar to either docetaxel, latrunculin, doxorubicin, or AZI? And then what we can see is actually they pull out wells that have a similar mechanism of action. One thing that this highlights, the use of the StrataMiner platform with open data, it highlights that what we can do is actually iterative data mining. So what we can do is we can load our open data that we've extracted from images, from the IDR or from the Broad collection, and then using StrataMiner we can extract new knowledge from that. Then this new knowledge can be turned into metadata that we can merge with our original data and then do another round of analysis. And so this is essentially iterative data mining. It's the same way that people iterate and do multiple experiments based on answers they find in experiments. We can do the same thing with the analysis of our data. One thing that our work with these open data also shows is the actual challenges of using the open data. In certain cases, you end up with data that is unusual or weird formats. Some of the files can be very large and can be hard to handle. Also, some of the metadata can be split between different files, and so this is a critical point where you have to merge them, you have to join them, and sometimes this can be a challenge. As you saw with our images, downloading the images is possible, but then you do need advanced tools in order to extract the features from the images. And of course, you need some tool like Strataminer for a biologist to be able to get some useful information out of the the numeric data. Another problem, of course, that has been addressed earlier is that there's a lack of standardization. Now, will it be possible for everything to be done in a completely standardized fashion? I don't think that's realistic, but one thing that can greatly help with this is proper tools that are flexible enough to allow people to pull in, data from various different sources. One thing you noticed as you browse the various data sets in the image repositories is that they're all quite different. Different types of biology, different cell systems, even different species. And so they're hard to compare like with like. Now, what if there was a standard assay that people could test their chemicals against and so compare different experiments? Well, there is a platform that might make that possible, and that's called cell painting. Now, cell painting is a fairly straightforward protocol that uses 5 different dyes that label different parts of the cell. 8 different cellular compartments. And what this generates is a very rich, high content assay that can be used to profile genetic reagents or various different chemicals. And then the idea is that if you build up a kind of a library of these profiles, maybe that would be useful for comparing and clustering with new chemicals or hits from new screens. And possibly you could compare between different experiments. And so this really would make open data from high content experiments extremely useful. And there are a number of consortia who are actually working on this idea, generating these libraries of profiles using cell painting. There's also a lot of interest in cell painting for things like predictive toxicology, where you could generate profiles of unwanted phenotypes, and then you could use those to predict unwanted phenotypes in novel chemicals that are coming out of screens. So I hope that gives you an idea of how we've been using open data and the possibilities and challenges of using open data. And I'd like to thank you for your attention, and I'm happy to answer any of your questions.
Thanks so much, David. That was amazing.
So
it's fascinating to see actual tools being used to visualize data, because when you've got so much data, you need these types of tools to actually try and understand them rapidly.
Yep.
We've got some questions coming through, but there's also a question that I'd like to ask is, firstly, when you're using open data and you're collating it, do you have any processes for publishing back data, some of the metadata that you're using and learning from?
So the type of work that we're doing at the moment is being published in kind of publications, and then that's at the moment that's how it's being done. So we don't at the moment have the ability to load reanalysis directly up into the original repository. So I think that could be very, very, very useful. And what you see in most of the repositories at the moment is, let's say, in the image-based repositories, you have the images, you have the metadata. You tend not to have the actual analysis that someone has done. But I really like that idea, is to link up people's kind of new insights into the data.
Maybe there's some people that could help you do that. Yeah.
You never know,
You never know.
you know, in Scotland, Jason Svedlow has been really done great work with that IDR image repository, and that's a very active project. His group are also behind a really powerful open source image database, as well as a set of standards for images. Of course, there's a huge number of different image types and file formats, and so they built an image standard platform called Bioformats, which allows people to import images with all sorts of different file types and then be able to manipulate them and use them. Yeah, so we're fortunate in that this is our our initial core market. We're a company. We're selling this software as a service, but we're lucky in that there's a great kind of community behind it that has built tools that allows people to do use open source image analysis and to generate data that they can then process in our tools. So it's a nice example of kind of synergy between open source communities, commercial tools, and various different and open.
And I think that's really important for people to understand, that it's the way these ecosystems work isn't just one company owns all this. The contribution back is just important, because the more you share, the more you get back.
Exactly. Yeah. We couldn't do what we do without open data, without people having access to various open tools. So, but obviously, there's also a place for companies to develop tools, because we have a real driver to focus, to maintain, and to
It's not as if there isn't a lot to do at the moment. So, and are there any? Have you got any examples of the COVID can give us at the moment?
Yeah, what we've actually done is that collaboration with Johnny Sexton at the University of Michigan. Coincidentally, he also did a COVID-19 screen. And so it's a drug repurposing screen. He had access to the appropriate viral facilities in order to be able to do an infection screen. And so he was able to do a drug repurposing screen where he tested, libraries of known drugs and got some very interesting data that's been published in bioRxiv. And he was using the Stratominer platform in order to analyze that data. And we jumped in and we gave him some extra help in order to help speed that up. So so that was it was great to be able to get involved with that. It was a lot of fun.
Yeah. Fantastic. Well, I'm going to finish off by thanking you so much for joining us, and asking you what's going to happen next. If you're going to cast forward a couple of years, what do you think is going to happen in the way that we all start using and visualizing data?
So one thing that I would be, and this is kind of a little bit out there. One thing we're very interested in is it's all about giving biologists access to tools that allows them to analyze their own data. We feel that this really speeds things up, and it makes it possible for the person who knows the biology best to come up with the analysis. At the moment, what we find is that, there's the real trade-off between complexity and ease of use. But what we would like to do is to build tools to help people to, analyze more unstructured data, just large matrices of data. So farther on in the kind of more public arena, I'd love to see something where, lay people could analyze data. When you look at things like the New York Times, where they are starting to use in-depth analysis and to make available these nice visualizations, as opposed to saying, oh yeah, okay, it's there, so that must be the answer, whatever. What if I can say, well, hang on a second, can I go in and do analysis of that data and then publish that in the comment section or something or whatever with visualizations, and go, well, here's their story, but actually they're ignoring the fact that this. And, what about that?
We're all for that. And I think that, that democratization of models as well as the data is something that we think is going to be the next iteration. And I think the focus, once we get the data right, we can then democratize those models, because I don't know about you, but whenever I scratch the surface of some of the models that people are using to make decisions, they are pretty shonky at times,
We could talk all day, but
yeah,
thanks
we could
very
indeed.
much.
Well, you know what? Maybe we can talk in person sometime when things settle down, and I'll get up there. As I said in the talk, I feel really bad that I haven't been to the north of England over the last couple of years. So it's definitely time to change that.
Thanks very much. And that gives me to say thank you to all the speakers this morning for Open Data Saves Lives. We're going to finish we're just ahead of schedule, which is amazing. We're going to finish now for an hour, and then we're going to come back this afternoon for responsible data collaboration, which we're really looking forward to. So thanks so much for David. Thanks so much to all the speakers this morning. We'll leave you now. Thank you.
Good stuff, Paul. Thanks a million. Take care.